Welcome to this video on relative frequency, which is part of the group of probability short videos. Relative frequency is an area of probability that looks at an actual trial rather than the mathematical probability. And sometimes we're asked to consider whether something is biased or not, in which case we would look at the mathematical probability to decide whether there was any bias. In this, I've drawn this again from the foundation paper, June 18. It's paper 1, which means it's non-calculator. We're just looking at question 27 in A and B rather than this one, which has nothing to do with probability. And in this first one, we're told that a coin is thrown 50 times and it lands on heads 31 times. So this is somebody flipping a coin 50 times and they're recording that it lands on heads 31 times. You'll note that I've written down here, and I've given you this, but obviously to balance it up to 50, we take 31 away from 50, 19 is the value, and that represents a number of tails that it lands on. The question is saying, write down the relative frequency that it lands on heads. So it's 31 times out of 50, so the fraction is 31 over 50 for 1 mark. And then the second part of the question, also just for 1 mark, the coin is biased towards head. This is what Raj is saying. He's the person presumably who's done this experiment. Use the data to give a reason why he might be correct. So again, if we think about the probability of a non-biased coin, it's half and half, or 50%, 50%. So if you throw it 50 times, you'd expect it to land on heads, in theory, 25 times, and on tails, 25 times. Yet in this scenario, it's actually landed 31 times on heads and only 19 times on tails. So that's kind of what you've got to say in the statement. I just said here, 31 is more than 19. It should be nearer 50-50 if not biased, or something like that. So that would address that question to give you the mark. Okay, we're going to have a look at another exam question, and again I'm going to send you some more for you to try yourself. This one comes from, it's foundation again, it's paper 2, so you can use a calculator. I've got my calculator here, from November 2017. So in this scenario, the relative frequency relates to an experiment that's carried out 200 times. And it's given the possible outcomes as K, L and M. They could be anything, it doesn't really matter. So part of the table's filled in, we've got to fill in the table, and then we've got to answer this question. So K, they're giving you that out of 200 times, it's landed 84 times. And L is landed 54 times. And we have a number of value here, relative frequency. So using the calculator, if we type in 84 over 200, press equals, we'll show the fraction, but again, if you use the STD key, you can see there that ties up with this, 0.42. So to work this one out, the relative frequency, all we need to do there is it landed 54 times if it was a coin tossing experiment or something like that, out of 200, 0.27. And of course the probability should add up to 1. So you can either do one of two things. You can take these two, add these two values and take it away from 200 to find that value, or take those two values away from 1. So let's do that. So we want 84 plus 54 gives us 138. And if we take that away from 200, that gives us 62. And we can do 62 over 200 gives us 0.31. So just to check, all those should add up to 1, so let's just do that on the calculator. 0.31 is just shown as answer here. 0.27 plus 0.42 gives us 1, so that's correct. So that will get you 2 marks. Now part B, altogether the experiment is carried out 500 times. How many times would you expect the outcome to be K? So looking at K again, we know the relative frequency is 0.42. and this time we need to times it by 500, the number of times the experiment's carried out. 0.42 times 5 times 500. So we'd expect it, using this relative frequency, to land or to occur on 210 occasions. So that's your working for 1 mark, that's your final answer for the accuracy mark. Okay, like I said, I'm going to send you some more of these for you to have a go at. I think it's a relatively straightforward area of probability, and we'll see how you go. Thanks for listening, and I'll be back to you next week with some more activities.